Welcome back, students, to chemistry. This is the beginning of Unit 5 and 6. Unit 5 and 6 are a combined unit. We'll tackle Unit 5, which is basically a single day, and then plow into Unit 6. So if you are in class, I will read from the book What If, and the question being, what if you had a mole of moles? But if you are not in class, you can find that with a simple Google search. What if you had a mole of moles? Today's lecture, though, on the mole. The mole is a furry burrowing animal in North America where this class is taught. However, it is not just that. The mole is a representative amount of something. Like when you say a dozen is 12 of something. Or if you say a pair is 2 of something. Or if we say a ream of paper is 500 sheets. We, in the English language, use words to represent numbers all the time, to represent groups of numbers. The mole is no different. We use the moles to count very, very small things, such as atoms, particles, ions, or molecules. A mole is 6 sextillion, which is an astronomically massive number. It is 6 with 23 zeros after it. So it is a huge amount. The actual number, a mole, is 6.022 times 10 to the 23rd. So if you have 6.022 times 10 to the 23rd of anything, that's like saying you have a mole of it. Much like if I had 12 eggs or 12 donuts, you would say I have a dozen of them. So we can use this conversion factor and dimensional analysis that you learned in Unit 1 to convert from things to moles or from moles back to things. So if I have half a mole, how many molecules of oxygen is that? If we set up our factor label method, half a mole, we can use the conversion factor that 1 mole is 6 sextillion of a thing. So 6 sextillion molecules would be 1 mole. Moles cancel out, leaving us with molecules of oxygen, which is what the question asked. So if we grab our calculator, we can type in 0.5 times 6.022. Now, times 10 to the 23rd, I highly suggest you do not use the times 10 caret on your calculator. Instead, you should learn to speak calculator. The calculator uses a uppercase E to say overload, to say that there is some massive number. So when the calculator needs to use scientific notation, it uses this overload function. So on your calculator, if I want a mole, if I want Avogadro's number of something, 6 sextillion, I want it to say 6.022 E23. To get that E, you hit the second button and then the comma, which is just above the 7. And that E takes the place of your whole times 10 caret nonsense. So 6.022 E23 is how you can express Avogadro's number, or a mole, in your calculator. And if we divide that number by 1, we get that half a mole would be 3.011 times 10 to the 23rd. Again, notice that your calculator expresses scientific notation as that E. So we have 3 sextillion molecules of oxygen. We can go the other direction. If I have 1.81 times 10 to the 24th atoms of gold, I can convert that into moles by using the same conversion. This time, however, I have atoms, so atoms needs to go in the denominator with moles in the numerator. 1 mole is 6 sextillion atoms. Atoms will cancel out and I'll be left with moles of gold. So I'll grab my calculator again and do 1.81, and again times 10 will replace with the overload function to the 24th, divided by 6.022 times 10 to the 23rd, Avogadro's number, to find that we have about a little more than 3 moles of gold. The next problem requires a little bit more work, as the next problem says how many atoms of each element are in 0.002 moles of sulfuric acid. Sulfuric acid has 3 elements in it, and we need to chop up these 3 moles to figure out how many atoms of each one of these elements are in this many moles. The easiest way to explain this is to be a little bit macabre and say, okay, if I have a person, I can chop that person up and I can get a heart and 2 lungs. Now I would do that because hearts sell for a lot of money on the black market, and so do lungs. So to supplement my teacher's income, my teacher's salary, I could chop up a person and make a bunch of money. So when I chop that person up, every person gives me 1 heart and 2 lungs. But if I chop up 2 people, I now have 2 hearts and 4 lungs. I can make a lot of money. Rather than chop up just say 1 person or 2 people, let's say I go on a homicidal killing spree and I take out my whole class. I actually have about 35 kids in my largest class, and they drive me crazy. So let's say I chop up 35 people and run away with all of my money to a warmer climate. If I chop up 35 people, how many hearts would I get? You're smart, you're pretty, and gosh darn it, people like you, and I know that you're able to tell me, Professor, that is 35 hearts. Very good. Now, here's the hard question. If I chop up 35 people, how many lungs do I get? Well, you would get 35 pairs of lungs, so you would get 70 lungs. Now, same principle. If you chop up 1 sulfuric acid, you would get 2 hydrogens, 1 sulfur, and 4 oxygens. But we're not chopping up just 1 sulfuric acid. We're chopping up 0.002 sulfuric acids. So we'll take that 0.002, and for each mole that we chop up, we get 1 sulfur, but we would get 2 hydrogens and 4 oxygens. So these change our numbers a bit. We no longer have 0.002 moles of each one. We would have 0.002 moles of sulfur, but we would end up with 0.004 moles of hydrogen and 0.008 moles of oxygen. Well, that's good information. That's not what the question asks. The question wants to know how many moles or how many atoms is that of each one. So we can use our factor label method to cancel out moles and go to atoms. 1 mole is 6.022 times 10 to the 23rd. Moles will cancel out, leaving us with atoms. And if we do that with each one, we'll find our answer. Since I want to do the same thing to all of these numbers, I could just put it in my list function in the calculator. So you hit stat, and then edit, and it will bring up a list. And I want to take list 1. So if I hit second 1, that says take list 1, and I want you to multiply it by Avogadro's number, 6.022 times 10 to the 23rd. My calculator will do that for me, giving me my answers. You would end up with 2.41 times 10 to the 21st atoms of hydrogen. 1.20 times 10 to the 21st atoms of sulfur, and 4.82 times 10 to the 21st atoms of oxygen. Doing that on your calculator is known as a batch transformation. It can make you work through a problem fairly quickly. Now, with that being said, you're able to answer all of page 19 in your packet. If you're in class, we also then talk about your mole analogy project. The mole analogy project is to use the factor label method to take 6 sextillion and boil it down to a number that is understandable and create a poster of sorts on a single sheet of computer paper. So for example, if you had a mole of donuts and you gave every person, and if every person in the world was to eat 1 donut a minute, you would find that it would take 176 years for every human on Earth to eat your mole of donuts. You'll notice that for this project, I came up with a snazzy little title. And then I started my analogy by saying if you had a mole of a thing and applied it to something massive, feeding the planet. You finish the project by giving me some assumptions. If everyone on Earth is going to eat a mole of donuts, the number of people on Earth can't change within that time. So I would assume that the number doesn't change. Also, this project was originally made in 2010 when the world population was only 6 billion. Obviously, today, when the world's population is about 7.7 billion, that number would be drastically different. So please give me your assumptions. If you're going to go to some far off place, some other planet, please tell me how far away that planet is, because due to the expansion of the universe, that number may change in the future. So you write me your assumptions. Lastly, you finish with calculations. In your calculations, you can have mathematical operators in Word by clicking on the Insert and then Equations tab. And you'll always start your equations with 6.022 times 10 to the 23rd. Now, if you want 23 to be an exponent, you're going to have to put in an exponent. So you'll have to come back in here and put in times 10 to the 23rd, which makes this 10 a little redundant. Then you can come in and say, okay, I want to insert a fraction and multiply by a fraction. In order to make this nice, you might want to insert some parentheses to say, hey, this is its own thing, where you'll do your first conversion. Your project is expected to be made in Word or a similar processor. Your project is expected to be neat and to include some sort of clip art to make it pretty. It needs to be in color. You do not need any page protectors. The library will print you a color copy of your project for 10 cents. This project is a test grade and it will take time. Your rough draft for this project will be due at the end of the first week that it is assigned. A rough draft will include your assumptions with your research and a beginning of your calculations. I do this rough draft so that I can look over your project and see if it will actually work out. Too many times I've had students say, I will just redo your example, professor, and say, if I had a mole of strawberries, how long would it take everyone on Earth to eat them? And I will not accept any of those projects. I am sorry, you need to come up with a novel or new-ish idea. So I suggest you take something very small and apply to something big. Grains of rice stacking to the moon, or if I had a mole of water bottles, how many times could I fill Jupiter? That would be an equivalent project. So with that being said, that's the end of this lecture, and next class we will use molar conversions to talk about where the mole actually comes from. Where does 6 sextillion come from? I will see you next time, and good luck on your mole projects.